Hi everyone, RANA SIR is here. How are you dears? Welcome to our RANA SIR educational channel. Today I will talk on a topic whose name is motion of center of mass. In this topic I will explain its concept and then I will apply its concept in numerical. Therefore, you concentrate on this live video from starting to end to develop, that is, improve your knowledge on this topic. Simultaneously, you also like and subscribe, that is, share this educational channel with your colleagues, friends, and students so that they can also update their knowledge on this topic. Okay, now one additional information I am going to tell you and you have to follow it positively. First of all, each and every student has to take one notebook and one pen, and then you have to sit at your location positively, properly, and safely to write all the data which are available on the blackboard and also those informations which are spoken by me. Okay, students, so you concentrate here from starting to end to develop good knowledge about motion of center of mass, okay, of object. Okay, now this topic I will explain in English first of all. So student who are reading in CBSE board or student who are reading in English medium, those students can understand its concept and also application of this topic. Those students can understand in numerical how the application of this topic can be done in numerical. Okay, students, so you concentrate here, and after explaining all those informations I will also translate into Hindi, so students who are reading in Hindi medium, those students can also understand its concept in detail. Okay, now here I am going to tell you, this is the class 11 physics, and that is available in both medium, that is in English and also in Hindi medium. Okay, now it is also based on NCERT pattern. It means that only one time the concept can be explained either in English or in Hindi, so we have to follow this concept. Okay, now topic name is motion of center of mass, that is also written in Hindi, that is Darman Kendra ki gat. Okay, now center of mass of object already I have calculated yesterday. Okay, so you follow that concept and then that concept I will utilize, and after utilizing then I will also calculate the velocity of the center of mass. Okay, so you concentrate here. Here I am going to explain. Before, when I have considered, that is I have drawn here x-axis and also along y-axis, that is here I am going to say this is the x-axis. So here I will write this is the x-axis and a line which is perpendicular to this x-axis I will say that is the y-axis. Okay, now in this case I have taken a several of objects, that is I have taken several of objects, and those objects I have combined with a line. So I have assumed the center of mass will be on the same line. So I have already considered the intersection of x-axis and y-axis, that is intersection point will be origin. So here I have written this is the position vector, and here I have written this is the vector r, and point I have written here a. Now I will say this is the object which has mass m. Okay, similarly I have taken another object which has mass m2, which has mass m2, and then its position vector I have to write here r2. Similarly I will say the center of mass will be a vector rcm. Cm stands for center of mass. Now another point I have to write here, that is CM. Now this object I will also join with origin. So after joining with origin, so I will say this is the object whose has mass mn. Okay. Now its x coordinate I can write here x1 comma y1 comma z1. Similarly, here I will write x2 comma y2 comma z2. Now this is the center of mass I have written. This is the point A, this will be the point B. Similarly, I will say this is the point Z and this will be the point C, and its coordinate I can write like this: xcm, that is the center of mass of the coordinate x. Similarly, ycm, and similarly I will write zcm. So center of mass of these object will be at the point C, and its x coordinate I can write xcm comma ycm comma zcm. So I have calculated the center of mass, that is rcm, which is equal to, I have written m1 into r1 plus m2 into r2 plus I have written as, here I am going to write y-axis. So this is the y-axis. Now here I have to write m3 r3 plus, I will put here mn into rn. So here I have to write divided by the sum of all masses. In other words, we can write here m1 plus m2 plus m3 plus up to mn. I have to write here. Okay, this is the center of mass of the given objects. Here there are n objects which are joined at a point C, and the coordinate of that point C I have written here xcm comma ycm comma zcm, because here x y z, that is the, there are three components. One is the unit vector along the x axis, and other is the unit vector along the y axis, and another axis is the z axis, which is perpendicular to the blackboard, that is the along the desta direction. Okay, so that unit vector I will say that is the unit vector n, that is unit vector k. Okay, so center of mass of all these objects I have calculated by using this formula. Okay, now further I am going to assume, suppose that m1 plus m2 plus m3 plus up to mn, this is also the summation of mass of all particles. So I can put here capital N. Here I am saying let. Okay, I am assuming here. Okay, so the sum of masses will be capital M. Okay, so after using this one, so I can put here RCM, which is equal to 1 divided by capital M. In the bracket I have to write like this: capital M, in the bracket I have to write here M1 into R1 plus M2 into R2 plus, and so on. I have to write mn into rn. Okay, I have to write. Now I will say this is the equation number 1. From equation number 1, I will multiply with an operator d by dx, because if quantity, suppose that x is equal to y plus 1, suppose that, so if I will multiply with 2 on both sides, so there is no any change. Okay, I can do it. Therefore I am going to multiply d by dt on both sides, and after multiplying I will get a value, and that value I will implement in the equation number 1. Okay students, so you concentrate here. I am going to write one statement. That statement will be as multiplying by d upon dt. This is a operator multiplying by d by dt on both sides on both sides of equation number 1. Here I have to put of equation number 1 we get. Okay, this instruction I have to write here positively. Okay, now on both sides I have to multiply with a operator, and that operator is d by dt. So if on both sides I will multiply, so there is any change in my equation, because this is also equation x to y plus 2 y plus 1, and I have multiplied on both sides with 2. This is a fixed value, so there is no change in my solution. Okay, so I can apply this concept here. Okay, I hope that you are understanding clearly. So here I will write r d upon dt. In the bracket I have to write r cm, which is equal to, here I will also write d upon dt. In the bracket I have to write 1 by 2. In small bracket I have to write m1 r1 plus m2 r2 plus dash I have to write here mn ran. Okay, I have to write there. So here I will put big bracket. So after using this in the equation number 1, then I have got this value. Okay students, I hope that you are understanding all these concepts clearly. Okay, therefore you like this live video, and then you share this live video with your colleagues, friends and students, so that they can also update their knowledge on this topic. Simultaneously I will I will also say to subscribe this educational channel more and more. Now here in the left hand side I also know distance divided by time, that is also known as velocity. Okay, so in next step I will write it, but first of all informations which are written on the blackboard I will also translate into Hindi, so student who are reading in Hindi medium, those students can also understand, that is get knowledge ऑन दिस टॉपिक. ओके, यहाँ पर कहा गया है मोशन ऑफ सेंटर ऑफ मास. इसको हिंदी में कहते हैं द्रव्यमान केंद्र की गति, द्रव्यमान केंद्र की गति. तो हम एक्स वाई प्लेन में जो होता है हम एन पॉइंट, दैट इज एन ऑब्जेक्ट, एन पार्टिकल, एन वस्तु लिए हैं. तो प्रत्येक पॉइंट पर मास है. जब कोई भी ऑब्जेक्ट है उस ऑब्जेक्ट का जो होता है द्रव्यमान होगा. तो इस ऑब्जेक्ट बिंदु ए पर जो होता है एक ऑब्जेक्ट है, एक वस्तु है जिसका द्रव्यमान m1 है. इसका x कोऑर्डिनेट, y कोऑर्डिनेट और z कोऑर्डिनेट यहाँ पर लिखा गया है. ओके, नाउ इसी तरीके से दूसरा कण है जिसको दूसरा पार्टिकल कर सकते हैं, उसका द्रव्यमान जो होता है m2 है, और इसका x कोऑर्डिनेट, y कोऑर्डिनेट और z कोऑर्डिनेट जो होता है वेक्टर के फॉर्म में रिप्रेजेंट किया गया. इसी तरीके से n पॉइंट पर जो होता है एक पॉइंट है जिसको हमने z लिखा है, लेकिन यहाँ का द्रव्यमान mn है. इसका मतलब n मास जो होता है हम इसे एक्स वाई प्लेन में हम लिए हैं, और इसका कोऑर्डिनेट हम लिखेंगे एक्सएन कामा वाईएन कामा जेडएन. दिस इज द कोऑर्डिनेट पॉइंट ऑफ, this is the coordinate of the point z. okay, so all information I have written. सभी इंफॉर्मेशन को हमने यहाँ पर लिख दिया. अब इसी जो लाइन ज्वाइन किए हैं, इसी लाइन पर जो होता है हमारा सेंटर ऑफ मास ऑफ दिस पार्टिकल्स विल बी देयर. तो सभी मासों का जो सेंटर ऑफ मास जो होता है वो पॉइंट सी पर हमने एज्यूम किया है, जिसका एक्स कोऑर्डिनेट एक्ससीएम स्टैंड होता है. इसका मीनिंग ये होता है सेंटर ऑफ मास. उसी तरीके से एक्स कोऑर्डिनेट का सेंटर ऑफ मास एक्ससीएम हो गया, वो आईसीएम हो गया. ये वाई कोऑर्डिनेट का सेंटर ऑफ मास है, इसी तरीके से जेड कोऑर्डिनेट का सेंटर ऑफ मास है. तो ये जितने भी ऑब्जेक्ट एन है, एन वस्तुएं, इस सभी वस्तुओं का सेंटर ऑफ मास एक ही होगा. उस वैल्यू को कैलकुलेट करने के लिए हम आरसीएम लिखेंगे m1 इंटू r1. r1 जो होता है ओ ए वेक्टर है, r1 वेक्टर को यहाँ पर लिख सकते हैं x1 वेक्टर i कैप प्लस y1 वेक्टर j कैप प्लस z1 वेक्टर k कैप। सिमिलरली सभी वेक्टर को लिखेंगे जो स्टैटिक के क्लास में ऑलरेडी एक्सप्लेन किए हैं। ओके, सो उन डाटा को सबको लिखने के बाद से हम लिख सकते हैं कि सेंटर ऑफ मास ऑफ ऑल ऑब्जेक्ट विल बी एज m1 इंटू r1 प्लस m2 इंटू r2 प्लस m3 इंटू r2 व r3 प्लस एंड सो ऑन mn इंटू rn। अब इसमें जितने भी मास है सभी मास का हमने क्या करेंगे, समेशन करेंगे, सम करेंगे। तो सम करने के बाद से हमने एज्यूम किया है कि जितने भी n मास है उन सभी मास को ऐड करेंगे तो एक मास मिलेगा जिसको हम कैपिटल M से रिप्रेजेंट करेंगे, इसलिए यहाँ पर लेट किए हैं। ओके, नाउ आरसीएम को सेम उतार दिए हैं और ये m1 m प्लस m2 प्लस m3 प्लस अप टू mn को 1/m के रूप में रिप्रेजेंट करेंगे। अब ब्रैकेट में m1 r1 प्लस m2 r2 प्लस डैश डैश mn rn लिखेंगे। इसको हमने इक्वेशन नंबर 1 कहा। अब यहाँ पे एक इंफॉर्मेशन है जो इम्पोर्टेंट है, इस इंफॉर्मेशन को यू हैव टू नो पॉजिटिवली। यहाँ पर कहा गया कि दोनों तरफ समीकरण नंबर 1 के दोनों तरफ जो होता है एक ऑपरेटर है जो डी बाई डी टी ऑपरेटर दोनों तरफ मल्टीप्लाई करेंगे। मल्टीप्लाई करने के बाद से हम एक्सप्रेशन जो बनेगा उस एक्सप्रेशन को लिखेंगे। तो यहाँ पे एग्जाम्पल के तौर पर कहें x इज इक्वल टू वाई प्लस 1 है। अगर इस इक्वेशन में अगर दोनों साइड में अगर 2 से मल्टीप्लाई करेंगे तो इस तरह के कैलकुलेशन में किसी तरह का परिवर्तन नहीं होता है, इसलिए दोनों साइड में डी टी ऑपरेटर से मल्टीप्लाई किए। मल्टीप्लाई करने के बाद से इसको हम लिखें। ओके, सो यू कंसंट्रेट हियर, आई विल सिंप्लीफाई this expression and after simplify I will get the velocity of center of mass of n ऑब्जेक्ट। ओके, तो n ऑब्जेक्ट का जो वेलोसिटी होगा, वेलोसिटी का जो सेंटर ऑफ मास होगा उस सेंटर ऑफ मास को हम कैलकुलेट करेंगे और इस कंसेप्ट को जो होता है हम न्यूमेरिकल में भी अप्लाई करेंगे ताकि इस कंसेप्ट को हम न्यूमेरिकल में भी इसका यूज कर सकें। ओके, नाउ all data which are available above side I will erase and after erasing I will simplify below data to reach to the destination. Okay, so above data positively I will erase and after erasing I will simplify below data above. So you concentrate here. Now here I will write d upon dt. So here I will write d upon dt. In the bracket I have to write RCM, which is equal to 1 divided by capital M. Capital M in the bracket I have multiplied this operator d by dt in each term. So there is n term. So in each term I will multiply and after multiply I will use its geometrical meaning. So here I will write d by dt 1 by capital M and then in the bracket I have to write m1 dr1 divided by dt. Similarly I will write m2 dr2 divided by dt. So I have to write all these value and then m3 dr3 divided by dt. Here I will write plus and so on. So last term I will write mn dr n divided by dt. Okay, positively I have to write it. Now further I will say now the formula for velocity, distance and time, that is velocity which is equal to displacement by time. Okay, displacement by time. So here vector r is displacement and t is time. So displacement by time, that is velocity. This is also distance by time, that is velocity. So here I will write vcm, that is 1 by m. I have to write 1 by capital M. In the bracket I have to write m1 and here I will write v1. This is the velocity, displacement 1 divided by t, that is v1. Similarly m2 v2 plus m3 v3 plus dash 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 I will write here mn and vn. This is the formula. This is the formula for calculating the velocity of center of mass of an object. Okay, so we have to remember this formula positively, and its application I will also do in the numerical. Okay, so you concentrate here. If we have to calculate velocity of center of mass of n objects, so I will use this formula, VCM, that is Cm stands for center of mass, and this center of mass will be of the velocity, that is 1 by m, and the value of m I know, m1 plus m2 plus m3 up to mn. So it's all sum of all masses will be the capital M. So here I have to put m1 v1 plus m2 v2 plus m3 v3 plus and so on mn vn. Okay, we have to remember this formula positively. Okay, now I will also write numerical, and in that numerical I will use this formula to calculate the center velocity of the center of mass of given objects. Okay students, so you concentrate here. We have to find, that is we have to calculate the requirement of the question. So this is the important, and this formula I have to write, that is I have to save here, that is VCM, that is velocity of center of mass, which is equal to, I have to write here 1 divided by capital N, in the bracket I have to write m1 v1 plus dash dash mn, here I have to write mn vn. So this value I have to write there, and then I have to implement in the numerical. So m1 v1 plus m2 v2 plus dash dash I have to write here mn and vn. Positively I have saved there, that is VCM is equal to 1 by m, in the bracket I have written here m1 v1 plus m2 v2 plus dash dash, it will go up to mn vn. Okay student, so I hope that you are understanding all these informations clearly. Okay, now so all these informations I will also explain in Hindi, so student who are reading in Hindi medium, those student can also understand its concept in detail. Okay, यहाँ पर हम दोनों इक्वेशन नंबर 1 के दोनों साइड में जो हम एक ऑपरेटर डी बटे डी टी ऑपरेटर से मल्टीप्लाई किए, मल्टीप्लाई करने के बाद से हमने ये एक्सप्रेशन पाया, तो इसको हम लिख सकते हैं डी सी आर सी एम बटे डी टी। तो आर सी एम बटे डी सी वेलोसिटी का ये फार्मूला होता है कि डिस्प्लेसमेंट बटे टाइम, डिस्प्लेसमेंट बटे टाइम को हम क्या कहते हैं, वेलोसिटी कहते हैं। यहाँ पर आरसीएम है तो यहाँ पर सरफिक्स आरसीएम लिखेंगे, यहाँ पर कैपिटल 1 बाई एम है, 1 बाई एम लिखेंगे, एम1 की जगह पर एम1, और डी आर1 बटे डी टी मीन्स ये वेलोसिटी 1 होगा, तो डी आर1 बटे डी टी को वेलोसिटी 1 कहेंगे, v1 कहेंगे, इसी तरीके से m2 v2 प्लस m3 v3 एंड सो ऑन अप टू mn vn. ओके, दिस इज द फार्मूला फॉर वेलोसिटी ऑफ सेंटर ऑफ मास ऑफ द n ऑब्जेक्ट्स. ओके, सो वी हैव टू रिमेंबर दिस फार्मूला टू calculate the requirement of the question. Okay students, so I will erase all these informations positively, and then I will write the numerical, and then in that numerical I will use this concept to evaluate the requirement of the question. Okay students, so you concentrate here. I am going to write the numerical, and then I will draw its appropriate diagram, and then I will calculate the requirement of the question by using this concept. Okay student, if you are understanding all these informations clearly, so you like this live video, and also you share this live video with your colleagues, friends and students, so that they can also update their knowledge on this topic, and simultaneously you also subscribe this educational channel more and more. Now I am going to erase it positively for writing one numerical which is based on this topic. Okay, now here I'm going to write one numerical. Calculate CALCULATE, calculate the velocity of center of masses of two objects. Here I am considering two objects. They have masses as 2.5 kg and 1.3 kg respectively. Also find its mass of its lowest mass of velocity, but mass which has higher highest weight, which has highest mass, that has velocity 15 meter per second. Okay, so in this numerical we have to use the velocity of center of mass to calculate the velocity of center of mass of two objects, and also we have to calculate the velocity of lowest mass. So I will also draw its diagram and then I will calculate both informations. Okay, so here I am going to give its solution. So first of all I will write given that. So here I will write solution, that is given that. So that given that information I have to write. Now M1, that is mass of first object, is 2.5 kg and it has velocity, that is velocity E1, which is 15 meter per second it is given. Okay, now the mass second object which has mass 1.3 kg, but it has no velocity. I have to calculate its velocity. Okay, I have to calculate its velocity, that is initial velocity. Its initial velocity is 0. Okay, so we have to calculate final velocity here. Okay, now I will draw its diagram. Now one object which is available here, whose mass is m1 and its velocity is given, that is u, 15 meter per second. Now 15 meter per second. So you concentrate here, I am drawing its diagram. Now second object that is available, em2, its mass is also given, but its velocity, initial velocity, that is u2, is 0. Now I will draw this information in the xy plane. So I will say this is the x coordinate, this is the y axis, and this is the x axis. So positively I have to draw it. So I am writing it as, so this is the x coordinate. So x coordinate I have to write here x axis, this is the x axis. Okay student, I hope that you are understanding all these informations clearly, because this is the x axis, this is the y axis, the angle between x and y axis is 90 degree. Now I have to draw, so these two line from the center of the circle. So I will say there will be a point here. I am saying one point is A, and other point here I am saying that is point B. Now center of mass of this point will be, I will say that is the C. Okay, so in this case I will say that object will have at this point, and its x coordinate will be xcm, comma ycm, comma zcm as per requirement. Okay, so we have to calculate the center of mass in the case of velocity. So we have to calculate velocity of center of mass of two objects. So you concentrate here, I am going to give its solution in detail. Okay, so first of all I am going to also explain all these informations into Hindi, so students who are reading in Hindi medium, those students can also understand its concept in detail. Okay, now यहाँ कहा गया इस क्वेश्चन में दो ऑब्जेक्ट है, ऑब्जेक्ट का हिंदी होता है वस्तु। एक वस्तु बिंदु ए पर रखा गया, दूसरा वस्तु बिंदु बी पर रखा गया है। जब दोनों वस्तु को जब ज्वाइन किया जाता है तो एक लाइन मिलेगा। तो सेंटर ऑफ मास जो होता है दोनों वस्तुओं को किसी एक बिंदु पर होगा। हमें मालूम नहीं है तो हमने मान लिया है कि सेंटर ऑफ मास जो होता है बिंदु सी पर होगा, लेकिन इस पॉइंट पर जो एक्स कोऑर्डिनेट, वाई कोऑर्डिनेट और जेड कोऑर्डिनेट जो होता है सेंटर ऑफ मास के रूप में हम रिप्रेजेंट करेंगे एक्स सी एम कामा एक्स वाई सी एम कामा जेड सी एम से। ओके, सो इन दिस केस हमको कैलकुलेट करना है इस दोनों ऑब्जेक्ट का सेंटर ऑफ मास कितना है। इसको कैलकुलेट करने के बाद से ये भी कहा गया है कि बिंदु ए पर जो ऑब्जेक्ट है, जो वस्तु है, उसका मास m1 है, उसका वेलोसिटी जो होता है इनिशियल वेलोसिटी 15 है, 15 मीटर पर सेकेंड दिया गया है। लेकिन जब बिंदु बी पर मास m2 है लेकिन इसका वेलोसिटी नहीं दिया गया है, जब इनिशियल वेलोसिटी नहीं दिया गया है तो उस केस में हमको बिंदु बी पर जो होता है उस इनिशियल वेलोसिटी नहीं दिया गया, तो सेंटर ऑफ मास के रिस्पेक्ट में उसका फाइनल वेलोसिटी क्या होगा। ओके स्टूडेंट, सो यू कंसंट्रेट हियर, आई एम गोइंग टू give its proper solution. Okay, if you are understanding all these informations clearly, so you like this live video and also you share this live video with your colleagues, friends and students so that they can also update, that is improve and develop their knowledge on this topic. Okay, now positively I am going to erase the above data because information of the question I have written, so I will utilize those information. So here I am going to write according to the formulas, that is I can write VCM which is equal to 1 divided by capital M. Already that formula I have saved here for solving this question. Okay, 1 by M which is in the bracket I have to write M1 V1 plus M2 V2 plus M3 V3 plus dash I have to write here Mn Vn. Okay, I have written there. Okay, you concentrate and you understand its concept in detail. Okay, now here there are two objects, one object which is located at the point A and second object which is located at the point B. So I will substitute its value. So here the value of M I have to write, that is one mass is 2.5 kg, 2.5 kg, and other mass is 1.3 kg. I have written here. Okay, now in the bracket I have to write m1, that is 2.5 kg, and the velocity u1, that is 15, plus second object whose mass is 1.3, and initial velocity of that object is 0 and 0. Okay, we have to calculate its center of mass, that is here I have to write 1 divided by 3.8, 5 plus 3, 8, 3.8. in the bracket I have to write its value as, I will multiply 2.5 into 15, that is I have to write here 2.5 into 15, I will multiply. So 5 5 ja 25, carries to 5 2 ja 10 to 12. So 5 1 ja 5, 2 1 ja 2. So I will add. So 5, this will be 7, this is 3. So I will use point after 1 unit. So 37.5, and this will be multiplication of any number with 0, that will be 0. Okay, student, I have to calculate this velocity of center of mass of two object that is given here. Okay, now below data I will erase for further simplification. So here I will write 37.5 divided by 3.8, and this is the DCM, and its unit will be meter per second. Okay, I hope that you know how to calculate the velocity of center of mass of two given object. Okay, students, I hope that you are understanding very clearly. Okay, how we have to calculate, because in the question there are two objects. So formula I have remembered, I have written here for n objects. So only we have to use two objects, one object which is located at the point A, and second object which is located at the point B, and C is the point where center of mass I have calculated. So center of mass at the point C, that is VCM, which is equal to 37.5 divided by 3.8. So point I can erase, I can eliminate by multiplying 10, dividing 10, and then I will simplify. After simplification I will divide above data below data by above data by below data, and then we will get its value in fraction. Okay, so this is the center of mass. Okay, students, so one solution of the question I have completed. Okay, now this is the center of velocity of the center of mass. Now we have to solve second point. Now here I will write velocity of center of mass, which is equal to at the point initial point minus final point. I have to write here initial point minus final point. So initial point is 1 and final point is 0. In other words, we can say that the center of mass of at other in will be that 37.5 divided by 3.8, which is equal to initial velocity will be 0, because that is not given in the numerical. So we have to find final velocity, that is V2. That V2 will be as, now I will simplify. After simplify V2, I will say that is minus 37.5 divided by 3.8, and its unit will be meter per second. This is the second answer of the given question. Okay, student, so according to this way I have to complete the any numerical which is given in the test. Okay, so this is the required way. First of all, I have to calculate, I have to explain, I have to derive the formula for velocity of center of mass of n object, and then according to that formula we have to utilize that formula in the numerical, because I have derived the formula for n object, but here there are two object is available. So we have to calculate the center of mass in terms of velocity, and also we have to calculate the velocity at half at b when that object will have final velocity. Okay, so that velocity can be calculated by using this concept, that is VCM, that is center of mass of object, which is equal to initial velocity minus final velocity. So initial velocity that is given in the numerical 0 meter per second, and so v2 can be calculated. So after simplify, v2 can be written, and this minus sign will go here, and then I can write like this. Okay, this is the second answer of my question. Okay student, I hope that all students who are reading in CBSE board are in English medium. Those students can understand this concept, how to calculate the velocity of center of mass of an object. Okay, now all these informations I will also translate into Hindi, so student who are reading in Hindi medium, those students can also understand this concept in detail. Okay, यहाँ पर कहा गया है कि अगर हियन पॉइंट पर हियन ऑब्जेक्ट दिए गए हैं, उनका मास दिया गया, उसका वेलोसिटी दिया गया है, तो उन सभी मासों के लिए हम सेंटर वेलोसिटी ऑफ सेंटर ऑफ मास कैलकुलेट करेंगे। तो उन सभी ऑब्जेक्ट को एक लाइन से ज्वाइन करेंगे, तो उन सभी ऑब्जेक्ट का सेंटर ऑफ मास जो होता है उस लाइन के किसी बिंदु पर होगा। तो उस बिंदु को हमने यहाँ पर एज्यूम कर लिए, क्योंकि एक क्वेश्चन में दिया गया है दो ही बिंदु है, तो मैंने उस बिंदु को सी कैलकुलेट किए हैं, मैंने एज्यूम के लिए मान लिया है। और सी पॉइंट का जो एक्स कोऑर्डिनेट, वाई कोऑर्डिनेट और जेड कोऑर्डिनेट जो होता है डिस्टेंस के फॉर्म में हमने रिप्रेजेंट किया एक्स सी एम, एक्स वाई सी एम और जेड सी एम। ये एक्स सी एम जो होता है एक्स एक्सिस के अलोंग जो होता है सेंटर ऑफ मास है, वाई सी एम जो होता है वाई एक्सिस के अलोंग सेंटर ऑफ मास है, और जेड सी एम जो होता है जेड एक्सिस के अलोंग। ये एक्स एक्सिस जो होता है हॉरिजॉन्टल एक्स एक्सिस के अलोंग होता है, वर्टिकल वाई एक्सिस जो होता है ग्राउंड एक्सिस पर जो होता है परपेंडिकुलर होता है, और जेड एक्सिस जो होता है दोनों एक्सिस पर जो होता है परपेंडिकुलर होता है, जो हम यहाँ पर डेस्टर से रिप्रेजेंट कर रहे हैं। तो एक्स एक्सिस के अलोंग यूनिट वेक्टर आई कैप, वाई एक्सिस के अलोंग वेक्टर जे कैप, और जेड एक्सिस के अलोंग वेक्टर के कैप हम लिखते हैं। ओके, तो मैंने वेलोसिटी ऑफ सेंटर ऑफ मास of an object already I have written here and its formula I have saved here. Okay, now इस क्वेश्चन में मैंने एक क्वेश्चन को एक्सप्लेन किया। इस क्वेश्चन में दो ऑब्जेक्ट है, दो वस्तुएं हैं जिनका मास m1 दिया गया है और उसका वेलोसिटी भी दिया गया है, लेकिन दूसरा मास है, उसका मास तो दिया गया लेकिन वेलोसिटी नहीं दिया गया है। तो सेंटर ऑफ वेलोसिटी ऑफ सेंटर ऑफ मास हम कैलकुलेट करेंगे तो सेम फार्मूला यूज करेंगे। कैपिटल एम जो होता है जितने भी मास होंगे सभी मास का सम होता है, जोड़ होता है। तो सभी मास को मैंने ऐड किया, उसके बाद m1 v1 प्लस m2 v2 हमने यूज किया। हम जानते हैं कि सेकेंड मास है उसका वेलोसिटी दिया नहीं है, इसलिए उसको जब दिया नहीं है उसको जीरो एज्यूम करेंगे। ओके, अगर अब हम देखते हैं कि किसी भी क्वांटिटी को जीरो से मल्टीप्लाई करेंगे वो क्वांटिटी जीरो है, इसको सिंप्लीफाई करेंगे तो वेलोसिटी ऑफ सेंटर ऑफ मास जो होता है ये हमको कितना मिला 37.5 डिवाइडेड बाई 3.8 मीटर पर सेकेंड हो गया। ये पहला क्वेश्चन जो होता है दोनों ऑब्जेक्ट का वेलोसिटी का सेंटर ऑफ मास हमने कैलकुलेट किया। ओके स्टूडेंट, अगर ये वीडियो आपको अच्छा लगा हो तो इस वीडियो को ज़्यादा से ज़्यादा लाइक करें, शेयर करें, सब्सक्राइब करें अपने कलीग के साथ, फ्रेंड्स के साथ और विद्यार्थियों के साथ, ताकि उनका भी नॉलेज इस अपडेट और डेवलप हो सके। ओके, नाउ अब कहा गया है कि जब दूसरा ऑब्जेक्ट है, जो दूसरा ऑब्जेक्ट बिंदु बी पर लोकेट किया गया है तो उसका मास दिया गया है लेकिन उसका वेलोसिटी दिया नहीं गया है, तो उसका वेलोसिटी हमने जीरो एज्यूम किया है। लेकिन जब सेंटर ऑफ मास मिल गया है तो उसके फाइनल वेलोसिटी को कैलकुलेट करने के लिए हम इस कंसेप्ट को यूज करेंगे कि उस वेलोसिटी का सेंटर ऑफ मास इज इक्वल टू जो इनिशियल वेलोसिटी दिया गया है, इनिशियल वेलोसिटी यहाँ पर दिया गया है u2, u1 का वैल्यू दिया है u2 माइनस v2 दैट इज फाइनल वेलोसिटी। इसका वैल्यू ऑलरेडी हमने एज्यूम किया, इसका वैल्यू कितना है 0 मीटर पर सेकेंड है। ओके, यहाँ पर सब्स्टिट्यूट सिंप्लीफाई किए, सिंप्लीफाई का हिंदी होता है सरल। जब इसको सरल किए तो v2 इज इक्वल टू होगा -37.5 बटे 3.8 मीटर पर सेकेंड। ये जो होता है सेकेंड requirement of the questionnaire. Okay student, I hope that you are understanding all these informations clearly. Okay, therefore you like this live video, and also you share this live video with your colleagues, friends and students, so that they can also update their knowledge on this topic. Okay, topic name is motion center of mass of an object, that is already I have written द्रव्यमान केंद्र की गति. Okay students, so you have to follow it positively. Now I will meet you on the same time, that is 30 minutes past to 7 o'clock to 30 minutes past to 8 o'clock, as per information we have to explain about the chapter number 6, that is the motion of center of mass. In this chapter I will explain next topic. Okay, and this is the class 11 physics, and I have to explain in both medium, that is in Hindi medium and also in English medium. Okay, if you need to learn in Hindi, so all data I have already uploaded there in my video section, so you go there and you read properly. And you need Hindi medium, so all data are already uploaded there in Hindi, so you can read easily. Okay, if you have any doubt, any confusion, so you write comment in the comment section positively, and then you send. After sending I will study, and after studying I will give the appropriate solution of your question in detail. Okay, thank you for watching this live video. I will meet you with you on the next day, that is on the same time, that is 30 minutes past to 7 o'clock to 30 minutes past to 8 o'clock. Jai Hind, Rana sir.